The next test in large sample test is nothing but test for single proportion and also test for difference of proportions, like test for single mean and test for difference of means. Here also for proportion you will have test for single proportion and difference of proportion. All these are large sample tests. You know that the basic steps in conducting any test is nothing but describing the sample data, writing the null hypothesis, writing the alternative hypothesis, writing the test statistic, its distribution and acceptation or rejection. These are the steps involved in any test procedure. So here the test for single proportion. So here the statistic on which we are concentrating is proportion. So let us suppose that we have a sample of size n, and proportion means it is related to the qualitative data. Means we are going to classify the how do you define a proportion? Proportion is nothing but whenever you are given a whole, a part of it is called a proportion. Here also, if you consider a sample of size n, and let us suppose that let A be the attribute or the characteristic under study. Means let us say that if you have a 100 number of different colored buttons, let us say that the red colored buttons are going to be the study and is a proportion you are going to calculate. Let us say that n is the sample size, and out of these n units, let us say that x possess this characteristic A. All these are related to sample. Let us collect a sample of size n, and we are studying the entire data with respect to any qualitative characteristic A. Let us say that out of these n samples, x are observed to have the characteristic A. Then how do you define the proportion? As we are using the sample here, we write P here stands for sample proportion. Proportion stands for P. Sample means you will write with lowercase letters. P is nothing but sample proportion. How do you define proportion? As in general, total in the denominator, and in the numerator number of individuals having the particular characteristic under study. Here P will be x by n. This P indicates the sample proportion of number of individuals having a characteristic A. So let us now, as you are classifying that the entire sample n into two categories, like having the characteristic A and not having the characteristic A, we are classifying the sample into two categories. We can term those as success and failure. So whenever we have only two alternatives, this x is a random variable which follows a binomial distribution. Again I repeat, we are classifying the sample into two classes. One, x as the number of individuals having the characteristic A, and what will be the remaining? N minus x as the number of individuals doesn't possess the characteristic A. So here x is a variable, obviously, moreover it's a random variable which assumes or which follows a binomial distribution. What are the parameters of binomial distribution? N comma capital P. Try to understand, always we write the parameters with which letter? Capital or small letters? Capital letters. So here x follows binomial distribution with n comma P. What is E of x then? Mean of binomial distribution is NP capital P, and variance of x is nothing but NPQ, where Q is nothing but 1 minus P. Now you have described what is the sample size, what is sample proportion, what is capital P as a population proportion. After describing the sample data, you need to write the null hypothesis H naught. What is the test here? It is a test for single proportion. So you should write that what is the null hypothesis? It is a hypothesis which shows that there is no difference between the population characteristic and sample characteristic. That is, here we write that there is no significant difference between the sample proportion and sample and population proportions. Likewise the mean, what you wrote the null hypothesis there is no significant difference between population mean and sample mean. Here instead of mean, here you are writing there is no difference between sample and proportion mean. That is nothing but P is equal to P naught. This is the null hypothesis here. What is the alternative hypothesis here? The alternative hypothesis here is nothing but P not equal to P naught. So, or otherwise we can write this as P is equal to P naught. Now, what is H1 here? P naught equal to P naught. Now, to define, as we are calling this X as a binomial variate. What are all these tests? These are large sample tests. We know that for large values of n, any distribution, moreover here binomial, for large values of n, binomial distribution turns to normal distribution. Binomial approaches to normal distribution, that is X follows normal distribution with mean expectation of X, means mean mu comma variance V of X. What is E of X here? E of X here is nothing but NP capital P and NPQ. So by using the central limit theorem, we can define a test statistic for large sample test. Always the test statistic we indicate with Z. Z is equal to, here X is the normal variate, X minus E of X by root over variance of X. I know you know, I think you know how to write the Z. Z as a standard normal variate, X minus mu by sigma follows N01. E of X is same as mu. So what is mean here? Here mean is NP, variance is NPQ. You will get Z is equal to X minus NP by root over NPQ follows N01. So as this is the test on proportion, let us divide the entire H's with n. X minus n by P, NP by P by root over NPQ by n follows N01. As you are dividing with n, when it goes to the square root, it is going to be squared. What is x by n is nothing but p, small p, minus n will get cancels by n root over pq by n follows N01. So under H naught the test statistic will be P minus P naught by root over P naught Q naught by N follows N01. This is the test statistic for single proportion, or simply you should write in the same way in the examination. To remember, you can write Z is equal to P minus expectation. This is the other way of writing the test statistic. P minus this by SE of P follows N01. P, expectation of P is capital P. What is standard error of P? PQ by N. But in the examination, here you should cover all these steps. So this is the test statistic. You will Z alpha by 2. What is Z alpha by 2? Is here critical value at alpha percent LOS from which distribution? Areas of standard normal distribution. You will compare with Z alpha by 2. Less than Z alpha by 2, you are going to accept. If it is greater than Z alpha by 2, you are going to reject. This is test on single proportion. I think if you know this, writing the test for difference of proportion is very easy. So let us discuss that also. So here, what is the test here? Test for difference of proportions. So difference means a minimum of 2. Here moreover it is confined only to 2 samples. So you should describe two characteristics regarding population as well as regarding sample. So let us, in the first one you have just described X and N. So here you should collect 2 samples of sizes N1, N2. Let N1, N2 be the sizes of 2 samples. Let X1 be the number of individuals having a characteristic A out of N. Let X2 be the number of individuals having a characteristic A in a sample of size N2. Means it's an extension of the single proportion where we have simply described one sample with X. Here you are writing two different samples n1 comma n2. X1 are the number of individuals having a characteristic A, x2 are the number of individuals having the characteristic A in another sample. P1 stands for sample proportion of the first sample, so this will be x1 by n1. What is P2? x2 by n2. What is the, as we are classifying again the sample into two categories, x1 is which variate? Is a binomial variate with parameters n1. As parameters you should write capital letter here. Parameter stands for population characteristics. Here x2 stands also follows a binomial variate with parameters n2 comma p2. So again the same one, you can write what is E of x1 here. E of x1 is n1 p1. E of x2 is n2 p2. Similarly, what is V of x1? n1 p1 q1. V of x2 is n2 p2 q2. You know that q1 is equal to 1 minus p1. Q2 is equal to 1 minus P2, means you have taken two samples with two sample proportions. Now, what is null hypothesis here? As this is the test for difference of proportions, here H0 is always the same. There is no significant difference between the two population proportions. What do you indicate the population proportions with? Capital P1 and P2. Therefore, P1 is equal to P2. I think you wrote the same in test for difference of means also. H0 such that mu1 is equal to mu2. Here it is mu1 P1 is equal to P2. H1 is P1 not equal to P2. You have described the sample data. You have specified null hypothesis symbolically and H1. Now again for large values of n. For large values of n1 comma n2 here, x1 follows normal distribution with mean E of x1 comma variance x1. x2 follows normal distribution with E of x2 comma V of x2. Now to write the test statistic here, test statistic under large sample test, you are going to denote that with Z always under large sample test. Here Z, how do you define Z here? Z as for the, you are writing this for the difference of proportions. Difference I think you will write with minus. So P, like how do you define Z is equal to x minus E of x by root of variance of x follows n01. So here for the difference means you are going to write P1 minus P2 minus E of P1 minus P2 by root over V of P1 minus P2 follows n01. This is P1 minus P2. How much you will get E of P1? On simplification here you will get E of P1 as capital P1, V of P1 as root over P1 Q1 by n1 using the standard error. What is standard error of proportion? Root over PQ by n. For this it is a standard error of variance of PQ will be root over P1 Q1 by n1. Similarly, E of P2 will be capital P2. V of P2 will be P2 Q2 by n2 using the standard error. So this is nothing but P1 minus capital P1 minus capital P2 by, you will get root over variance of P1 plus variance of P2. You know this one using your previous results. P1 minus P2, this term will be 0 as under H0 you are considering P1 is equal to P2. So this entire term will be 0. What will be Z then? Z is equal to P1 minus P2 by root over variance of P1 is nothing but P1 Q1 by n1 plus P2 Q2 by n2 follows n01. This is the test statistic. Again I think you can use the same decision by taking Z alpha by 2 as the critical value. When mod Z is greater than Z alpha by 2, reject H0. When mod Z less than Z alpha by 2, accept H0. Okay, thank you.